In this video, we'll be finding the area of sectors and segments. Now, in case you don't know what these are, sector of a circle is a part of the interior of a circle bounded by two radii and an arc. So here we have a sector. The radii are shown with the dark green line segments, and then the arc is this dark green curve. The segment of a circle is a part of the interior of a circle bounded by a chord and an arc. So here we have a segment. The chord is shown here, this line segment in dark blue, and then the arc is shown here, this curve in dark blue. Okay? So a sector and a segment. The area of a sector is a fractional part of the area of the entire circle. Now remember, the area of the entire circle is given by the formula area equals pi r squared. So this sector, we can actually see that it's 1/4 of the circle, but we could, if we wanted to, just write 90/360ths of pi r squared. And we know that 90/360 will simplify to 1/4, but that's not necessary. Just remember that if you're in degrees, if you're giving your sector in degrees, you'll put that degree measure over 360. For this sector that's kind of shaded gray, we could find that area by 60/360ths of pi r squared. And this one, now it's a little different because the central angle is given in radians, but we can still do the same thing, the fractional part. We have 2 pi over 3 over the total number of radians in a complete circle is 2 pi. And then that fraction of pi r squared. Now we could simplify this complex fraction by multiplying top and bottom by 3. And we would simplify to 2 pi over 6 pi, which we can see the pi's cancel, and 2 over 6 is the same as 1/3. So this sector would be 1/3 pi r squared. Now, the area of a segment is the difference between the area of the sector and the area of the triangle formed by the radii and the chord. So if you want to find the area of a segment, remember a segment is bounded by a chord and an arc. Then you need to find the area of the sector, like we did up here, and then subtract from that the area of the triangle formed by the two radii and the chord. And recall that the area of a triangle can be found with the formula 1/2 AB sine C, where A and B are the two sides of the triangle, and C is the included angle. So in this case, when we're finding the area of a triangle needed for the area of the segment, the two sides, A and the B, represent the two radii of the circle, and then the angle C is the central angle. So let's do a problem. The problem that we'll be doing, directions tell us to find the area of the segment bounded by an arc. So here's our arc. And the arc measures 0.6 radians. And the chord joining the endpoints of the arc in a circle of radius 10. So we need to make use of the fact that the measure of the arc is equal to the measure of the central angle. So this central angle is also 0.6 radians. But we're finding the area of this segment right here. So the area of the segment is equal to the area of the sector minus the area of the triangle. And the triangle is the figure that's formed by the two radii and the chord. Alright, so our area of our sector, remember it's a fractional part of the area of the whole circle. So 0.6 is the measure of our central angle. And the entire circle measures 2 pi radians. So these are both in radians. So that fraction times pi r squared. Now r is 10, so I'm going to put 10 squared here. So this is our fraction, 0.6 over 2 pi, times pi r squared. And then subtract from that the area of our triangle, which is 1/2 AB sine C. We can do that because this side measures 10 and this other side also measures 10. So there's our two sides and the included angle. So 1/2 AB sine C. So 1/2 10 10 sine 0.6. Our formula from the other page, remember our area of our sector was theta over 2 pi, and it's theta over 360 if your central angle is in degrees, times pi r squared minus 1/2 AB sine C. Let's do that on our calculator. Now we're in degrees right now, so we need to change that to radians. Right, now I'm showing in R, so my calculator's in radians. These pi's will cancel off, since this pi is in the numerator and this pi is in the denominator. So 0.6 divided by 2 times 10 squared, subtract, and then I'll enter 0.5 times 10 times 10 times sine 0.6. So the area of our segment is 1.768. My units are feet, so this is feet squared.